Picture a quiet afternoon in the living room. You place a toy on a soft blanket, hide it behind a little screen, and slide a second toy right next to it. You lift the screen away, and somehow there is only one toy sitting there. And so 1 + 1 has equaled 1. Your baby stares. She stares long and hard, locking eyes on that solitary toy, as if the physics of the room are suddenly broken. We are often told that babies arrive as blank pages, empty vessels waiting for adults to patiently write in the basic facts of the world. But developmental researchers read that reaction differently. They use a tool called the looking time method. When an event matches a baby's expectations, their gaze wanders. When an event breaks the rules of reality, they pause and stare. That extra second of attention is their way of saying, wait, that is mathematically impossible. That prolonged, puzzled gaze reveals that infants arrive equipped with a pre-installed sense of mathematics. To see how this built-in math operates, we can look at this logic map detailing the infant brain's two mathematical pathways. We focus on this first pathway, a system dedicated to handling very small, precise quantities, typically between 1 and 3 items. In the early 1990s, psychologist Karen Wynn tested this exact system. She set up a stage for 5-month-old babies, covered a single object with a screen, and let the infants watch as a second object slides in behind the same screen. Logically, 2 items should be there. When the screen drops for an impossible reveal of only 1 object, the babies immediately lock onto the error. Researchers ran the experiment in reverse, pulling an object away so that 2 - 1 should equal 1. Once again, when the researchers manipulated the final count to be wrong, the babies' eyes lingered on the mistake. They were actively keeping track of the inventory. For these tiny amounts, the infant operates as a precise tracker. She holds individual objects in strict mental balance, long before she has the physical coordination to hold a spoon. But what happens when the amounts scale up? If you place a pile of 10 objects in front of a baby, that precise tracking system gets overwhelmed. To find the limit, researchers Fei Xu and Elizabeth Spelke tested 6-month-old infants to see if they could recognize large groups without actively counting. This visualization compares the amounts they used. On one side, we have 8 dots, and on the other, 16. The infants easily recognized this clean 2-to-1 ratio. But when the researchers narrowed the gap to 8 dots versus 12 dots, the infants could no longer reliably tell the difference. This is the brain's second pathway in action, the fuzzy estimator. For larger groups, the infant brain abandons exact counting and relies on rough, ratio-based proportions. This instinct for more versus less extends far beyond humanity. It is an ancient, multi-sensory tool shared across the animal kingdom, used by creatures to quickly identify a richer foraging spot or choose a larger, safer group to join. This dual-engine math sense is original, evolutionary hardware. It is present and active within days of birth. All of this raises a highly practical question. Does this built-in infant hardware actually matter for a child's academic future? A team at Duke University followed a group of 6-month-olds to find out. They started by tracking the baby's visual attention, measuring how sharply they noticed a screen that constantly shifted back and forth between 8 dots and 16 dots. This line graph maps out the long-term data tracking those exact children years later. It shows a direct, positive correlation. The infants who scored high for noticing ratio differences at 6 months demonstrated higher mathematical proficiency at 3.5 years old. Formal school math relies on this existing architecture. When children sit down to learn written symbols and equations, they are reaching back and translating the primitive intuition they have carried since infancy. If you are raising a child today, it is easy to feel overwhelmed by the pressure of early academics. Parents are often told they need flashcards, drills, and specialized programs to keep a toddler from falling behind. The mathematical software is already running in your baby's mind, long before the first flashcard arrives. There is no installation required. Your role is to simply narrate the small, ordinary moments of your shared life. Count their toes out loud. Compare who has more food on their plate, or count the blocks as you stack them. By wrapping spoken language around these everyday interactions, you naturally connect their ancient feeling of quantity to our modern mathematical words. So the next time your baby fixes you with that long, thoughtful stare, you know what is happening behind those eyes. Your child is a quiet mathematician, waiting for nothing more than your gentle attention to help that knowing grow.